Axiomtek. Axiomtek.
'Hello, jom. Let's Sembang AIoT. Today is a very special occasion today. I think this is number 9. Yeah, good afternoon, everyone. Same thing. Me and 𝐀𝐮𝐬𝐭 still doing a live for you in the this near to weekend. I don't know whether it's good to do on the near to weekend on Friday. Previously we were doing this one on Thursday. Yeah. So I hope. But can you hear me? Yeah, I think some of you have been watching us on the live YouTube, on Facebook, and also some of the other channel. Is it? Do we? Yeah. So we have a different channel in this live. We actually broadcast to some of this live channel. Yeah. So how are you today? So I hope everyone is doing good. What is the hottest topic today? Nowadays.
Oh, everyone talk about the election.
Okay. I thought it's a LLM. LLM. What? The other day we were talking about LLM. What's LLM? What's LLM?
I don't know. What's LLM?
It's a large language model.
Oh.
Large language model used in the ChatGPT. I don't quite care about this LLM, but one day, actually LLM is one of the it's a large language model used in the ChatGPT. That is the thing that I got to know. Yeah, of course. Other than LLM, like what 𝐀𝐮𝐬𝐭 say is PRN. PRN is also very pilihan raya. What call pilihan raya negeri. Yeah. PRN is very hot nowadays. Yeah, so very good afternoon. I think some of you may be watching us in other parts of the world. Good afternoon or good evening or good morning. Yeah, so thank you for watching. For some of you who just start to watch us, okay, we have this Sembang AIoT. Of course, we explained before. Sembang it's in the Bahasa Malaysia. It's actually chit chat. Yeah, Amil, is it chit chat? Sembang?
Yes.
Yeah, it's not talking nonsense now, okay? But this is of course a very technical channel. I do not know. This is a number 9 already. Yeah, this is number 9. Have you got any feedback on other people talking about? Hey, are we talking too technical? You know, what do you think? So far, no. I think we are not so much deep into technical. We are talking about those surface thing, applicable things like that. Yeah, but more important thing today, I think we try to do more on the smart manufacturing area where AIoT is being used, especially in the digital transformation in this IR4. As you know, in one of the 9 pillars, AI and IoT is one of the 2 key pillars, yeah, used in the digital transformation and also IR4 related. Yeah, that is why also we want to stress on this, especially on the smart manufacturing. How can you use AI or IoT? I believe some of you, maybe I can start asking a question. How many of you or how many of your clients in the manufacturing area which has encountered some manpower shortage? Yeah, so manpower shortage can help or not AIoT? You know.
Yeah, can.
Yeah, say can. So it's we are definitely AIoT is able to help. Then how to help? Today we have a live demonstration also to you. If you want to know more, then you can keep watching, and then we are going to show it to you. What about in smart manufacturing? Do you face any efficiency issue? How can you improve the efficiency? Can we use AIoT to increase the efficiency?
Yeah, of course can.
Yeah, of course. So that also leads to our topic today. We are going to talk about the overall equipment efficiency, which is largely used in all the manufacturing process, where OEE stand for,
I just already mentioned overall equipment efficiency.
Yeah, overall equipment efficiency. Of course, when we talk about efficiency, how to improve that, that will be our next coming subject that we are going to discuss. Yeah. Before I start, maybe I don't know whether can you see this? Can you see this one clearly? Can you see a windows here? Okay. I think you can see a windows here. Do you know what is this? Do you know what is this? Today we have Amil helping us to set up, the AI part of it. Yeah. So do you know what is this? It's not relay. This is basically an EEPROM programmer. Why I want to bring up this one is because when we talk about IoT, we cannot run away from electronics. We cannot run away from electronics. We cannot run away from any programmable thing. Yeah, you should know what is this. Yeah. This is EEPROM. EEPROM stands for erasable program read-only memory. Erasable read programmable read-only memory. Basically it can be read, but it can be erased also. How do you erase? So this is very, very, very sophisticated, because this one nowadays you can't see this one anymore, because this windows is actually for you to put under the sunlight. Nobody put on the sunlight for this case. It's basically keep mainly all those programmers, doing firmware programmer. Basically, we are talking about this low level. You create assembly language, you create C codes, writing C code, assembly language. You want to, after you compile, you want to burn into we call it burn, or we want to burn into the EEPROM, or you put onto the EEPROM programmer. Yeah, there is a thing called EEPROM programmer. I think you hardly see this thing anymore.
I think I never see this thing.
Yeah, you put in the EEPROM programmer, you put a clip, I was discussing with one of the old friends, oh yeah, this one, when you take out, you have to clip it like that, So that is where you program. After you program, what happened is you have something wrong on the program. You want to do debug. After debugging, you say, oh, I want to change the program. You know how easy to rewrite this one program into this EEPROM? Actually, very easy. You go there. You either, if you don't have an ultraviolet, there is a called EEPROM eraser lah. Okay, there is a inside got this what they call the ultraviolet light. You put it inside, you put it there for 10 minutes or sometimes 15 minutes. If you don't have ultraviolet light, I personally, put on the sunlight before. Or I will take some time to really 100% erase the thing inside. So after erase, then you put on the EEPROM programmer, you compile your program, then you load it again. Is it easy? Easy or not?
Not very easy.
Of course, it's not easy. Nowadays, how we do? How these people do?
We just click a button and delete everything.
We click a button, then we erase, then we reprogram again. So I want to bring up this one is because some of you, of course, if you are as old as me, then you have, of course, you have seen this one before, like Amil, our friend, very young friend. This is not relay. This is an EEPROM. I don't know whether it's still in the syllabus when we is in the electronic syllabus. I don't think maybe they don't teach anymore. Oh, these are the big, very.
I think there should have some introduction, but introduction talk more in detail.
So after the EEPROM actually is evolved to a flash. Evolved to flash memory. That's where solid state, memory, all this come about. That's how you can use. Ken say, you can right now practically you can just click a button to erase, and then you can program again. Yeah. So last time is you had to rely on the natural sunlight, or of course not natural sunlight. There is an EEPROM eraser. You put it inside. Usually, you will have when you do programming, you have to have 5 or 6 pieces, so that you can put everything inside. So when you change program, you take a new one, the empty one, to program. Then this one you put it inside to erase. Okay. So you have a rotating things like that. Yeah. Just want to share with some of the young engineers. Yeah. So probably you have used that before. So that I think should be about 25 years ago. So of course, talking about that, we have one this PC. I just by nowhere, I don't know how this one just pop up. It's just about 2 weeks ago. So I saw this one. This is about 25 years old. Yeah, this board is 25 years old. That is also, I'm also one part of the engineer who tried to design this board. Yeah, but why I want to bring up this one is because this board is practically used for doing some counting and also doing some detecting of the machine operation, on, off, and things like that. Then it has a industrial IoT Wi-Fi bus linking to a system or PC. Yeah. So that is how we, you see, overall equipment effectiveness or OEE has been very long time in the most of the manufacturing plant. So this is some of the way last time, we use. But of course, right now, that's why I want to show it to you. In order to do this function, okay, in the whole OEE process, we have 3 main components. What are they? What are they? We have this availability,
and then quality. And one more is
performance. Yeah, APQ lah. It's basically APQ. So availability, how do you measure the availability? For those of people who are running a production, or you are one of the production manager in the shop floors, how are you going to measure your availability? Of course, availability, you sit down there and you mark, oh, this operator, got work, okay, he start working. Oh, suddenly he go to toilet, oh, he's not working anymore, something like that. Of course, those are very manual operation, but what about those automated machines? Automation machine, usually you have we call it a stack light or tower light that give you maybe 3 or 4 or even sometimes 6. Let's say talk about three combination. giving you a green light, red light, and also the orange color light. I have this picture here. Maybe you can, we can just share with you. This is how some of these, what you call the machine is being tracked using the so-called tower light or stack light. So by using this device, it makes you very easy already, So you can see on the picture there, run, loss, test, what is that, hold, These are all the status telling you how much time that is actually consumed during the state. For example, from a red to green or from green to yellow or something like that. Those combination would give you indication. This guy, this guy is able to measure that for you. You don't need to care at all. It will give you a very in a split second kind of accuracy. So this one is able to give you the availability. So of course, availability. Why are you having this kind of different what they call the combination of different status? Okay, so when you talk about sometimes machine, automated machine may be running to short of material. It give you some light, or it stopped because of what? Maybe with some blinking light. That also tell you the one of the status of the machines. Of course, after having this availability, you are going to have the other one we talk about quality. The performance. We talk about performance. Performance, it can also be tracked over here because inside this module is able to give you how do you measure the counter, the counter value. This counter value can be tapped from, if let's say you are using the automated but old machine, you don't have any output. Probably you can tap on to certain counter, nearby, that able to give you this pulse. This guy can measure. At the same time, also, when pulse changing state, you can measure the cycle time. How long does your product being produced from one to the other? So that is the cycle time. So that's why from this unit itself is able to give you the two important parameters already. One of them is availability, in different state, and also the performance on the what you call how well, how fast your product being produced. Okay, and plus, of course, when you talk about you can measure the cycle time, you automatically able to know what is quantity produced. Okay, if you have the quantity produced, if let's say your product is running into different bin, let's say, so good, you come here, bad, you go the other side. So by itself here, if you are put into check to this signal, you are able to measure how many bads or how many good. So from there itself, you basically just now when you say we have an A and P, the last one, the quality, you are able to measure the quality, how many rejects or how many goods one. Of course, on the detail side, that's why today detail side is not able to give you, but with the assist of AI, vision AI, you can even define how the data can be come in later, for to make up the whole the OEE calculation. At the same time, also here it comes with the Wi-Fi. It's working very well with our IoT Edge Gateway, where you can program. To gather. But right now, this one is already mostly are all set properly. You plug it in, data will come in. This guy is able to do calculation. Your OEE is automatically shown. If you look at the picture again just now, we have in the picture you can see the bottom is actually blocked by me and 𝐀𝐮𝐬𝐭 there, the small one, and then the upper one, you can use we have this HMI. This is one of the way, okay? This is one of the way how it can be implemented. Of course, there are many other ways, but I think this way is very what they call easy to manage, very easy to handle. With this HMI, you can see the whole for this particular machine, or it can be linked to multiple machines. You can flip into the pages, show you what are the OEE value and so on. Yeah, this is another way. Maybe we can switch over the other side. Okay, the last part is after having all these things, you are able to publish this thing to the cloud. Like in this case, we have this AIoT Edge Connect. That is a cloud level. You can visualize. You can do what they call the tabulation of your data, historian, and then you can send alert. If you want to send alert, to some of these or those people who look after the production. So that is one of the way to measure the OEE. At the same time, also it will give you you are able to manage the efficiency of the process. Yeah. So it can be that easy. Okay. So with all these things, of course, the data being published is from our IoT Edge Gateway. So that actually is able to publish directly. Yeah. So of course, having this whole thing about OEE, of course, just now we mentioned about something to do with on the quality side. The quality side. So how are you going to further define the quality? Later on, I think 𝐀𝐮𝐿 is going to be able to show you. But before we come to that part, what are you going to show today?
Okay. For today, we'll show you how to use the AI to perform the abnormality detection on the PCB board.
Okay. So this is one of the example. Yeah, one example. Of course, here 𝐀𝐮𝐿 is having a PCB board here. This is not so much on the chip detection, all those things. This is more on the visual inspection. So let's say visual inspection, you take about, normally we take about 1 minute to do some visual checking. This is our old process. I'm talking about wave soldering process. Yeah, we are talking about wave soldering process. So by using this one, you take about 1 minute to do one board. Okay. Later on, maybe we can see how we can do this one in the faster way.
Yeah.
This one you're going to show us in a faster way. Yeah. So basically, those are first time following us. If you have any question or if you have any comment, please do give us some feedback. Yeah, give us some feedback. You're always welcome to give us more comment to make this life more meaningful or more useful for you, in the near future. But then, before we come to that thing, practically, this is considered the AI vision AI part.
Yes.
What is the main difference between the conventional vision inspection, we call it AOI, and the AI? Maybe you can explain first before.
Okay. So for the conventional, like the AOI, you need to, okay, of course they already provide the software for you, but you need someone who is expert using this software to help you to fine-tune all the parameters, so that it can maybe to detect the defect or some scratches or some component missing. But when you change to another board, you might need to call the supplier or the service provider come to you again to do the fine-tuning again. And then by this one is the conventional way. And then the new way is we are using the unsupervised deep learning, or we call it unsupervised AI. If you don't know the meaning of deep learning, you can treat it as an AI. So that one is we are using the good sample only to train the AI. And then when you show a bad sample to the AI, it will tell you which part contain the abnormality.
I see.
So when there's a new defect come in, appear on your board,
Okay.
yeah, it will automatically detect it. And then if you have a new board, you just need to provide the good sample of your new board, around few hundred. I think it's not an issue for you guys because good sample is very easy to obtain compared to the bad sample. So just provide the image, retrain the model, then it will do the task for you again.
Okay. So 𝐀𝐮𝐿, just now you are going to tell us how this using AI or using the manual inspection, because basically you are trying to tell us, you can demonstrate to us how you can reduce the manpower, right?
Yeah.
this part you're going to tell us, right?
Yeah.
So let's see what are the things that you can in this live, how can we show to us?
Yeah, okay. So I think now we'll share the screen of our camera.
Oh yeah, we have this live camera stream on the other side. We have another camera, which our gentleman Amil is helping us to check on this thing. Yeah, this is a simple setup by Amil, right?
Yes.
Okay, just a simple setup. This very prototype kind of thing. Yeah. So we intend to bring this one in those people who are attending the Smart Nation in September. We are going to have a proper setup there to demonstrate that to you, in the Smart Nation 2023. Yeah, you can go ahead. How?
Yeah. Okay. Of course. Over here you can see we have this one is the lighting. It will provide some lighting source, so that it will eliminate some reflection from our surrounding light. And then this one is a camera over here. Here, this is the camera. And then the bottom one, the green color thing, is the PCB board. Okay, now we change to another screen where our software is running.
I hope it's okay. Can you see? I hope you can see.
You can see clearly.
Yeah, you can see a Quadtel. Yeah, this is basically a 1 or 2G module. Okay. Yeah.
So for this one, we are checking the solder part. So seems like this one is a good sample.
Okay. So it's going to check on the soldering, soldering point, some solder bridge, or some joint not proper, or solder too much, or things like that. Yeah. Okay.
So now we change to another board, the back sample.
It's not easy to show live like that, but you guys managed to do it. Well done. Okay.
Okay, now we focus
Share.
on the software.
Okay,
now as you can see over here, the AI able to pick up all the region that contain the abnormality.
So you see on the top part there is a solder joint. On the left hand side also some solder joint, not done properly, all those things. Those things can be marked, those considered AI data. So how do we able to keep track of this defect? How are you going to present this defect? Let's say we can tell how many type of defect there is. How many defect?
Yeah, we can count how many defects appear
at which zone.
At which zone also possible to do it.
Yes. Yeah. These are some of the things. Later on, those defect can be captured also, right?
Yes.
Can be captured and then can be logged. Yeah. So after watching this one, do you have any question that you want to ask? Please, you are welcome to ask us. But before that, maybe Amir, you want to throw a wire inside it. Let's show the.
Let's say if there's a new defect appear.
Let's say this. Wow, your wire is so huge. So it's also able to tell you the part, where you check, there's a defect. This is just to simulate to you, so that we do not need to always build the AI model.
Yes.
So you just do once.
When there's new defect come in, you no need to worry.
So you need to get the almost ideal one first lah. You need to get the most ideal one. So in this case, this is applying to the PCB. So how fast does this process is able to be done?
Okay, since this one is running on the CPU only, so for one camera string, we can achieve 10 frames per second. So every 1 second, you will get 10 results.
Okay. Every 1 second can take 10 results. So let's say we say,
Usually we say we manually checking, we require 1 minute to complete it.
Yeah.
And then now in 1 second, we already can get 10 results.
Yeah. So that is only on one person. Of course, we can put multiple cameras to do one shot, to do this kind of checking. Okay, this is one of the example that a very nice thing. So that is actually able to help you to improve the part of the efficiency, right? So you see, like that, just now I mentioned about this OEE, that's one of the quality. You can also pipe some of this AI data to tell me how many reject, how many good. Those actually is able to contribute to the whole OEE calculation. Yeah. So very nice. Thank you very much. Maybe we just expand a little bit from here. Maybe we just want to expand a little bit from here. What is the main difference between the object detection? Previously we done some object detection, object classification. What is the main advantage of this model?
Okay, so for the object detection and object classification, usually they are performed by using the supervised deep learning or supervised AI, where you need to provide the labels to tell the AI model what are the objects you want to detect, and then what is inside this image. So the AI able to do the classification for you. But for this one is the unsupervised AI. So you only prepare all the good image or the good sample only. You don't need to mention which part is good, which part is bad. Only the good sample. Then the AI will extract all the good feature from the good sample, and then it will learn which part is the important thing.
I see. So just now we said we are only using the processor or CPU to perform the AI only.
Yes.
Yeah. So is that capable of? Is there a performance improvement if let's say we add in some GPU to do that?
Of course, the GPU is more powerful than the CPU. Of course, you can get a higher frame per second, but at the same time, your cost will be increased also.
Yeah. Okay. So that is a trade-off that you can measure lah. Let's say you can do this one in 1 second already. So you want to cut down to 0.5 seconds to do that. You actually can. Then you have to measure how much cost that you want to increase.
Yes.
But the overall AI model, when during the training for this model, do you use a GPU to run that?
Yes.
Yeah.
For training the AI model, of course, we need a GPU to run it to reduce the training time. If we are only relying on the CPU to do it, it might take a few months to complete the training.
I see.
By using the GPU, for this one, I think we only spend around 5 to 10 minutes. Then it can complete the training already.
Okay. So just to highlight again, this part is unsupervised learning, unsupervised deep learning. This is deep learning, but unsupervised deep learning. So for those of you who just starting to watch us, this is a Jom Les Sembang IoT channel. So of course, always I like, we always beg you for the SSL, share and subscribe and like, So I hope if you want to watch us in the next coming session, so please do SSL. So, but then just before I end, I think I just want to have a quick overview about, let's say, in future, I actually want to hear more from the audience where which part of IoT or AI that maybe you want us to tell you more, yeah, or which one you want to tell, to which topic that you want us to discuss. But for this case, I think overall, in the manufacturing, these are considered one of the key operation, or we call it key process that you need to do, because it's related to efficiency. When you have a good efficiency, of course you have a cost reduction, you become more competitive. Yeah. So other than that, OEE, there is another layer of OEE where you actually keep track of what are the quality issues, correct? What are the quality? How can you improve? With the right data, you can improve. Of course, OEE, the whole thing talking about the efficiency, all the data, all the root source are from availability, So how can you make sure you have a good availability? Yeah, good availability come from, let's say, your automated process. Yeah, so you bound to have more defect. Say not defect, I mean downtime caused by this thing, and downtime caused by the other thing, and downtime. So with that, of course, you can manually find out where are all these possibility and how you can improve that. But I think right now, the whole OEE is no longer that game. That game is considered, just now what I said, all this game is considered, I would say, consider a little bit obsolete because it's already used. But is it valid or not? Is it practical? It's very valid, it's very practical. But why I say it's obsolete is because, there is such thing called data-driven. Yeah, so we talk about data-driven with AI, how can you tap onto that? So that's why in the third consideration of the OEE is giving you all this data, you are able to build another model which allow you to do optimization on the OEE itself. Yeah, so efficiency and optimization play around together. That is supposed to be the future, right?
Yes.
That's supposed to be the future. So we are working very hard in order to achieve that. That's why data collection, don't think data collection is not important. In order to materialize the third consideration or third approach to this OEE, what are the things that is most important? Is the data, right?
Yeah, the data.
Yeah.
To collect data.
So start collecting your data. If you are not doing that, please, you can start collecting, even though you don't do any analytics. Later on, that can be your one of the important, what you call the important key important ingredient that able to give you more optimization in the later part. Yeah. So with that, I think, do you have anything to say, any more? I think you want to share?
Yeah, I think no more.
So that's all for today. Of course, the technology is to help us to amplify the efficiency, as I always say. Technology is to amplify the efficiency. If you want to get the technology, please look to amplify the efficiency. Look at the AIoT. Yeah, and if you are finding some project to on this AIoT or AIoT project, also think about Axiomtek. But before that, I just want to share you before we leave. We have this upcoming event on the IoT Edge DigiHub happening on August 22nd. And we are inviting our product manager from Taipei. He is going to tell you more about how you can, it's basically, it started all from here. He's one of the, this is one of his baby. Of course, they have many other hardware platform. If you want to know how node rate integration on the DigiHub, you can do that with a different what it called API. He's going to talk about more deep inside the API. That is one part. On the 22nd, you can scan the QR code to follow us. And then we have another one. Of course, me and 𝐀𝐮𝐬𝐭 is working on some of these area like IoT AI. We do have this IoT digital transformation awareness training program. It's 1-day training program. You can take a look and then send the QR code. You can find out more in our this QR code. And then yeah, with that, we want to thank everyone, our audience. I want to thank you and follow us in the next session. Next session, we are going to talk about something related to the deeper level on some of the IoT. So we will see you in the next session. Thank you very much.
Thank you.
Bye-bye.